In this video, I will provide a quick explanation of Dirac's theorem. So here's what this theorem says. If a graph G with n greater than or equal to 3 vertices, so a graph with 3 or more vertices, has the property that the degree of every vertex is at least n divided by 2, then the graph contains a Hamiltonian circuit. Now, what is a Hamiltonian circuit? Well, that's a path that starts and ends at the same vertex and passes through each vertex of a graph exactly once. So let's check out these two graphs that I've created down here, and let's use Dirac's theorem to determine if each graph has a Hamiltonian circuit or not. So let's consider this first graph here. We have 5 total vertices, which I've labeled A through E. Dirac's theorem says that if the degree of every vertex is at least n divided by 2, then the graph contains a Hamiltonian circuit. So n, the total number of vertices in this graph, is 5. So n divided by 2 would be 5 divided by 2, which is 2.5 or 2.5. So we need to find the degree of each of these vertices in the graph and see if they're all greater than 2.5. Now recall that the degree of a vertex is just the number of edges that are connected to the vertex. So for example, if we look at vertex A, we can see that there are 2 edges connected to it. So vertex A has a degree of 2. So right away we can tell that this graph will not have a Hamiltonian circuit because already the first vertex that we checked does not have a degree greater than 2.5. Now, just for extra practice, we could go ahead and label the degree of every other vertex in the graph. And when we do that, we'll see that only one vertex actually has a degree greater than 2.5. So no Hamiltonian circuit exists in this graph. In other words, there's no way to start at one vertex, walk through the graph using the edges, and end back at the same vertex by only touching each vertex once. So for this one, we will write no Hamiltonian circuit. All right, now let's check out graph number 2 right here. So we have 5 total vertices in this graph. So in other words, n is equal to 5. So once again, n divided by 2 is going to be 5 divided by 2, which is again 2.5. So Dirac's theorem says that a Hamiltonian circuit exists in this graph if all of the vertices have a degree greater than 2.5. So let's go ahead and label the degree of each vertex in this graph. Alright, so when we do that, we'll find that each vertex does indeed have a degree greater than 2.5. So that means a Hamiltonian circuit must exist in this graph. Now, as an example of a potential Hamiltonian circuit, consider if we started at vertex A, and then we traveled to B, then E, D, C, then back to A. This is an example of a Hamiltonian circuit where we touch every vertex exactly once and we start and end at the same vertex. And that's just one example of a Hamiltonian circuit. So another one could be start at vertex A, then travel to B, then C, then E, D, and back to A. So that's another example of a Hamiltonian circuit. So those were just 2 quick examples of how to use Dirac's theorem to determine if a graph has a Hamiltonian circuit or not.